In this lesson, we will learn the definition of a real number, and we will examine some properties of real numbers. To begin, a real number is any number that can be shown on the number line. So the following numbers are examples of real numbers. Now, an important feature concerning real numbers is that with the exception of 0, all real numbers are either positive or negative. 0 itself is neither positive nor negative. Now on the GRE, if a question involves an unknown value, we can assume that the value can be any real number unless we are told otherwise. Now among the set of real numbers, there is one type of number that is of particular importance, and that is the integer. Integers are numbers such as 0, 1, 2, 3, and so on, as well as -1, -2, -3, and so on. Now on the GRE, you will often encounter questions where you are specifically told that some unknown number is an integer, so you will know that the number must be from this set of values. Alright, let's return to the set of real numbers so we can examine some of their properties. To set up these properties, let's say that a, b, and c are real numbers. If this is the case, then our first property is a plus b must equal b plus a for all real numbers. In other words, when it comes to adding numbers, we can reverse the order of the numbers and the sum will remain the same. For example, 3 plus 8 gives us the same sum as 8 plus 3. We call this property the commutative property, but you don't need to memorize this for the GRE. Just know that when it comes to addition, we can reverse the order of the numbers and the sum does not change. Also know that some operations are commutative and some are not. For example, multiplication is commutative in that we can reverse the order of the numbers and the product remains the same. So, for example, the product of 2 times 5 is the same as the product of 5 times 2. The product is 10 in both cases. Now, subtraction, on the other hand, is not commutative. In this case, the order of the numbers does matter. For example, 4 minus 5 does not equal 5 minus 4. Now please note that we are not saying that a minus b never equals b minus a. For example, if a and b both equal the same number, such as 5, then a minus b will indeed equal b minus a. All we are saying here is that it is not necessarily true that a minus b equals b minus a. In other words, subtraction is not commutative for every pair of numbers. Similarly, division is not commutative for every pair of numbers. For example, 6 divided by 2 is not equal to 2 divided by 6. Now the next property says that the sum of a and b plus c is the same as a plus the sum of b and c. So for example, if we want to find the sum of 1, 4, and 7, finding the sum of 1 and 4 first, and then adding 7, produces the same results as adding 1 to the sum of 4 and 7. The property demonstrated here is called the associative property, and we say that an operation is associative if changing the grouping, or brackets, does not change the results. Given this definition, we can see that multiplication is also associative. For example, if we take the product of 2 and 3 and then multiply that by 4, the result is the same as multiplying 2 by the product of 3 and 4. Now subtraction, on the other hand, is not associative since changing the brackets changes the results. The following example demonstrates this. Similarly, division is not associative as is demonstrated in this example. Now the next property is called the distributive property, which is illustrated by this example. This property says that the product of a number and a sum is equal to the sum of the individual products. In other words, a times the sum of b and c is equal to the product a times b plus the product a times c. The following example demonstrates this. 3 times 8 plus 2 is equal to 3 times 8 plus 3 times 2. Now please note that the distributive property also works when the numbers in the brackets are being subtracted. For example, 10 times 7 minus 3 is equal to 10 times 7 minus 10 times 3. Now the last set of properties concern the numbers 1 and 0. First, when we multiply any number by 1, the product is always that number. Second, when we divide any number by 1, the quotient is always that number. Next, whenever we multiply a number by 0, the product is always 0. And whenever we add 0 to a number, the sum is always that number. Finally, any non-zero number divided by itself is always equal to 1. In an upcoming lesson, we will examine what happens when we divide 0 by itself. Okay, let's summarize. In this lesson, we learned the definition of a real number, and we learned some important properties of real numbers. In this lesson, we'll learn how to perform addition and subtraction on signed numbers. And by signed numbers, I mean positive and negative numbers. Now, before we continue, I should point out that this is a very basic lesson. So if you're confident in your ability to add and subtract positive and negative values, then you should feel free to skip the lesson. Okay, let's begin. We'll start with adding a positive number to any value. Now please note that we typically place brackets around negative numbers to avoid confusing the negative symbol for subtraction. Conversely, if a number does not have a sign, then the number is assumed to be positive. So in the first example, we are adding positive 3. In the second example, we are adding positive 7, then positive 2, then positive 6, and then positive 4. Now I should mention that in this lesson, we will use integers to show how positive and negative numbers behave. Just remember that the same rules apply to all signed numbers, that is, integers and non-integers. Now when it comes to adding a positive number to another number, the rule is to move to the right along the number line. For example, if we want to add 2 plus 3, we take the number line and start at 2. We always start at the position of the first number. And from here we move 3 spaces to the right, 1, 2, 3, and end at 5. So 2 plus 3 must equal 5. Similarly, to find the sum of negative 6 plus 4, we begin at the first number, which is negative 6, and then move 4 spaces to the right, 1, 2, 3, 4, and end at negative 2. So negative 6 plus 4 is equal to negative 2. Finally, to find the sum of negative 3 plus 7, we begin at the first number, negative 3, and then move 7 spaces to the right to end at 4. So negative 3 plus 7 equals 4. Now that we have covered adding positive numbers, you can practice with these sums to see if you get the following results. Next, we will learn how to subtract a positive number from another number. Notice that in these examples, we are subtracting a positive number each time. Now, when it comes to subtracting a positive number from another number, the rule is to move to the left along the number line. For example, to evaluate 4 minus 3, we start at the position of the first number, which is 4, and from here we move 3 spaces to the left, 1, 2, 3, and end at 1. So 4 minus 3 equals 1. Similarly, to evaluate negative 1 minus 2, we begin at the first number, which is negative 1, and then move 2 spaces to the left to end at negative 3. So negative 1 minus 2 equals negative 3. Finally, to evaluate 4 minus 6, we begin at the first number, 4, and then move 6 spaces to the left to end at negative 2. So 4 minus 6 equals negative 2. Now, if you want some more practice, try these questions here and see if you get the following results. Next, we will learn how to add a negative number to another number. Notice that in each of these examples, we are adding a negative number. Now, when it comes to adding a negative number to another number, all we need to do is recognize that adding a negative number is the same as subtracting a positive number. In other words, a plus some negative number b is the same as a minus the positive version of b. For example, to evaluate 2 plus negative 3, we first rewrite it as 2 minus positive 3. Now we already learned how to subtract a positive number. The rule is to move to the left along the number line. So for this question, we start at the position of the first number, which is 2. And from here we move 3 spaces to the left to end at negative 1. So 2 plus negative 3 is the same as 2 minus 3, and this is equal to negative 1. Similarly, to evaluate negative 1 plus negative 4, we first rewrite this as negative 1 minus 4. Then we begin at the first number, which is negative 1, and move 4 spaces to the left to end at negative 5. So negative 1 plus negative 4 is the same as negative 1 minus 4, which equals negative 5. Finally, to evaluate 3 plus negative 7, we first rewrite this as 3 minus 7. Then we begin at the first number, which is 3, and move 7 spaces to the left to end at negative 4. So 3 plus negative 7 equals negative 4. If you want some more practice, try these questions here and see if you get the following results. Finally, we will learn how to subtract a negative number from another number. Notice that in each of these examples, we are subtracting a negative number. Now, when it comes to subtracting a negative number, all we need to do is recognize that subtracting a negative number is the same as adding a positive number. In other words, a minus some negative number b is the same as a plus the positive version of b. So, for example, to evaluate 2 minus negative 3, we first rewrite it as 2 plus positive 3. Now, we already learned how to add positive numbers. The rule is to move to the right along the number line. So we start at the position of the first number, which is 2, and from here we move 3 spaces to the right to end at 5. So 2 minus negative 3 is the same as 2 plus positive 3, and this is equal to 5. Similarly, to evaluate negative 1 minus negative 4, we first rewrite it as negative 1 plus 4. Then we begin at the first number, which is negative 1, and move 4 spaces to the right to end at 3. So negative 1 minus negative 4 equals 3. Finally, to evaluate negative 3 minus negative 1, we first rewrite it as negative 3 plus 1. Then we begin at the first number, which is negative 3, and move 1 space to the right to end at negative 2. So negative 3 minus negative 1 equals negative 2. If you want some more practice, try these questions here and see if you get the following results. Alright, that concludes part 1 of a 2-part series on operations with signed numbers. In this lesson, we learned how to add and subtract signed numbers.